definitions today before we start drawing circles. The first one, a polygon is inscribed in a circle if all of its vertices are on the circle. Let's go ahead and write that out. A polygon is inscribed a circle if all of its vertices are on the circle. So what you want to do is draw a circle. And I'm just going to inscribe a triangle. So if I say that triangle ABC is inscribed in circle O, all of its vertices are on the circle. So this is my example. Triangle ACB or ABC is inscribed in the circle. So when you say something is inscribed, it's within. If you say something is circumscribed, which we're going to learn a little bit later, it means around. Okay, and the next one. A circle is inscribed in a polygon if the sides of the polygon are tangent to the circle. The sides of the polygon are tangent to the circle. So I'm going to go ahead and draw another circle. And let's go ahead and mark its center. And it's inscribed in a polygon. So I'm just going to choose to inscribe it in a quadrilateral. And hopefully it will work out. Okay? So all of these lines that I put around the circle are tangent to the circle. And when a circle is inscribed in a figure, the center of the circle is known as the incenter of the polygon. Doing just a bit of vocabulary today. All right, so when something's inscribed, that means it's within. Inscribed is within. And now the opposite of that is around. A polygon is circumscribed about a circle. It is if each of its sides is tangent to the circle. Each of its sides tangent to the circle. Polygon is circumscribed about a circle. So it may not look any different than the diagram we just drew. So you could say here that if I label this A, B, C, D, and I called this circle P, I could think of it two ways. I could think of it that ABCD, the quadrilateral, is circumscribed about circle P. Or I could say that circle P is inscribed in ABCD. We'll take a moment to let that sink in. Circumscribed means around, and inscribed means within. So it just depends on which word you want to use, because you can describe the same situation using either word. Is that clear? The way I always remember the difference is, you might have remember when you learn about the explorers, and they say so-and-so, I should know this but I forgot, was the first person to circumnavigate the world. What does that mean?
To go around.
First person to go completely around the world. not going to take a guess. So the word circum means around, and I appreciate your maturity. Okay, definition. A circle is circumscribed about a polygon if the polygon's vertices are on the sides of the circle. So we draw a polygon. It's still handy to draw the circle first, and we've already drawn it up above. Now I'm going to make the polygon a square. So the definition is the same. The circle is circumscribed about a polygon if the vertices of the polygon are on the circle. Now in this context, when the circle is around a polygon, the center of the circle is known as the circumcenter. Circumcenter of the polygon. And the words incenter and circumcenter are handy to know when you're reading a problem in your textbook and it's describing a diagramless problem. All right, so turn the page. And they want you to go ahead and draw this in number 1. And it says quadrilateral ABCD is inscribed in circle O. Now, if it's inscribed in, where are you going to put the quadrilateral? Kind of gave it away. Nikki. Inside. So that means the vertices are on the circle. Now, it didn't say that it's a square or any type of quadrilateral, so I just drew 4 vertices. And I'm labeling it A, B, C, D. Now, if quadrilateral ABCD is inscribed in circle O, what's the other way to say it using the other vocab word? Joel.
Circle O circumscribes quadrilateral ABCD.
Perfect. Or circle O circumscribed about quad ABCD. Circumscribed about ABCD. Nice. All right, now let's take a look at number 2. Pentagon is circumscribed about circle R. So is the pentagon going to have its size tangent to the circle or its vertices on the circle? Tangent. All right, so this one's a little harder to draw. 1, 2, 3, 4, 5. I did a really stand-up job of drawing that pentagon. And the other way to say it is that circle O is what? Victoria. Perfect. And I used the wrong letter. It should be R. Circle R is inscribed. Okay. Now back up at number 1, what is the center called? Circumcenter, yes. When the circle is on the outside, it's called the circumcenter. And when the circle is on the inside, it's called the what? In-center. All right, 2 more theorems and then we'll do some practice problems. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. And the last one is that if a parallelogram is inscribed in a circle, it must be a rectangle. So those are the 2 theorems that you would use in a proof type situation. Let's go ahead and illustrate that last one. I'd like you to draw a circle. And let's draw a parallelogram. Woo! Sorry. So parallelogram means opposite sides parallel, right? So Let's start by trying to make my opposite sides parallel. Well, you can kind of just tell by looking at it that, well, it looks like a, it looks like a rectangle. But we don't assume things just by what it looks like. Well, the reason that it becomes a rectangle is that that center, or that diagonal rather, goes through the center. Now, that means that each of these angles are what type of angles? They're right angles. So we know that a parallelogram with a right angle makes a rectangle. So if ABCD is a parallelogram, ABCD is parallelogram, we know that AC, oops, I can't draw a diameter today. That did not go well. Let's try this again. AC and BD are what? No, not necessarily. AC and BD are what type of segments in the circle? Diameters. You have radii, A, if you mark the center, like AO and OD, etc. And because it's a rectangle, you have opportunity to use Pythag. All right, I'd like you to take a look at page 41 and go ahead and work with a partner and try to get done 41 and 42.